I'm Anil Kumar sharing with you a practice question on integration. We'll use the technique of substitution to integrate this particular function. You need to integrate 7 times x to the power of 4 divided by e to the power of x to the power of 5 d of x. Now here what you observe is that derivative of x to the power of 5 is x to the power of 4, kind of, right? 5 times that. Anyway, once you get that kind of a derivative of a derivative, that means the origin could be from chain rule of differentiation. We could apply substitution. So the substitution which we could do here is we could write u as equals to e to the power of x to the power of 5. Now in that case du will be equals to derivative of this, which is derivative of x to the power of 5 is 5, x to the power of 4, e to the power of x to the power of 5 d of x. So that becomes the derivative of this. Now in the given integral we can substitute for x to the power of 4 dx. So let me just kind of rearrange this, right? So what you could write this as, this is like u factor, right? So we could think like this, 5, this is u for us, right? So 5u times x to the power of 4 d of x, that is du. Now if I have to substitute dx, I will substitute that by what term? That's what I'm looking for. I could combine x to the power of 4 and d of x, these two, right? Since they are very much a part of our integral, so let me rewrite this integral to show you how we are developing the substitution. So we could write this integral as integral of 7 outside, since this is a constant, right? 1 over e to the power of x to the power of 5, this is exponent, x to the power of 4 d of x. Do you see that? Now we have this part which could be substituted, right? This part. And we have also found that u could replace that part, right? So we are left with just the numbers and u. So I think we are good to go. So what we will do now here is that we can think about writing this side as, we'll divide by this, 1 over 5u du is equal to x to the power of 4 dx. Do you see that? Now taking that into consideration, what we will do here is, that is the kind of substitution we are going to do, right? So we'll write this again as equal to 7 integral 1 over e to the power x to the power of 5 is, we know this, right? So 1 over this will be u to the power of minus 1. Is that okay? And then we have x to the power of 4 dx. X to the power of 4 dx is 1 over 5. So we are substituting this part, which is 1 over 5 u, right? So again we could write this as u to the power of minus 1, correct? That is, let me rewrite this here. So x to the power of 4 dx is 1 over 5 u to the power of minus 1 du. Is it okay? So we wrote this part as 1 over 5 u to the power of minus 1 du. Do you get it? Now that really gives you a simpler expression. 5 could be taken out, so 7 over 5 integral of u to the power of minus 2 du. Do you see that? Now that is, the power rule can be applied now. So we could write this as 7 over 5 u to the power of, so you have to add 1, so it is minus 1 divided by minus 1 plus a constant c. Now, so that is the negative 1, right? So it becomes negative here. So we'll replace u by the substitution which we did, which is e to the power x to the power of 5. So what we get here is minus 7 over 5, and we'll write this as such in the denominator, e to the power of x to the power of 5, correct? Plus c. Do you see that? So that is how we can integrate the given expression with the help of substitution. I'd like you to go through these steps and understand how we rearranged here so that easily we could simplify the integrand and then do the needful. I'm Anil Kumar. You can always share and subscribe to my videos. Feel free to share with them, and if you like, you can put a like. Thank you, and all the best.